दोस्तों आज हम सीक्वेंस एंड सीरीज के कुछ एक्स्ट्रा प्रॉब्लम्स करेंगे एक्सरसाइज 9.2 की बेसिक कॉन्सेप्ट्स आपको पहले एक्सप्लेन कर दिया गया था. नाउ यू सी दिस क्वेश्चन. व्हाट इज द क्वेश्चन? सम ऑफ द फर्स्ट p q r terms of an AP are a b c respectively, then you have to prove that a upon p q minus r, b upon q r minus p, c upon r p minus q is 0. So we can start from let capital A be the first term and R capital D is the common difference, or you may take this smaller d also. So now we are taking this capital D as the common difference. So according to question, this SP is given to you as A, SQ is given to you as B, and SR is given to you as C. So we can apply the formula of Sn. Sn is, this is P by 2 2A plus P minus 1 D. This is equal to A. Similarly from here, that Q by 2 2A plus Q minus 1 D is equal to B, and similarly R upon 2 2A plus R minus 1 D is equal to C. So from these you can find, you have to find A upon P. So A upon P you can take it as, if I remove P from here I can write this P here. If I remove P then I can write this Q here. If I remove R then I can write R here. So you can see you have value of A by P as 1 by 2 2A plus P minus 1D. Similarly B by Q as 2A plus Q minus 1D upon 2. Similarly C upon R is 2A plus R minus 1D. Now we are going to put these values in the LHS of what you have to show. So now we are just doing this side. So we are writing here LHS. So LHS you can directly put all the values. A by P is, this is 1 by 2 2A plus, this is P minus 1 B, and this is Q minus R. So let it be Q minus R, then plus 1 by 2, and B upon Q is 2A plus Q minus 1 D, and bracket is, you can see the bracket is R minus P. So this is R minus P plus 1 by 2 2A plus R minus 1 D, and this is, last one is P minus Q. So this is your LHS. Now we are going to just simplify this. You can take all like terms together. So you see that 2A, if you open this bracket, this will become A, and you multiply this term by this A Q minus R, multiply, and this multiply by this term A, and multiply by this term. So I am taking all like terms together. So this will become, A will be common because you multiply this 2, so 2 get cancelled, and A into Q minus R. So first I am getting Q minus. So now from here 2 will cancel, and then A into R minus P. So you can write this R minus P from here. Then you can write this P minus Q. So all terms which contains A, you have taken them together. Now all the terms, this time we'll take all the terms which will have D. So if you multiply 1 by 2 into this term, this complete term, you see what you are going to get. You are going to get D by 2 P minus 1 into Q minus R, because this will also get multiplied by this term. So I am going to take 1 by 2 D common, and P minus 1, and this will be Q minus R. Similarly here in this term, this is D, 1 by 2 D, you can take this this kind of bracket you can use. So now from here you will get Q minus 1 R minus P plus, and from here r minus 1 and this is P minus Q. Okay, now we can see, simplify, we can do the simplification. This Q will get cancelled, this Q, this R cancel, this P cancel. So this is A into 0, and here you see this is 1 by 2, this is D. Now we open the bracket, this is PQ, this is PR minus, this is minus Q, and this is R. From here, this is QR, QP minus R, minus plus P. From here, RP minus RQ minus P, and this will be plus Q. So now you can see this term will become 0 because A into 0 is 0, and here 1 by 2 D. Now you see all terms, PQ, it is positive here, you can see PQ somewhere will be negative also. Yes, you can see this PQ, this cancel. PR is negative here, you can see PR is here positive, Q is negative here, and Q is positive here. This is R positive, R negative, P, R, this cancelled, this P and this P cancelled. So ultimately this is also coming 0. So it means your answer is coming 0, which is equal to RHS. Now question number 12, it's given that sum of m terms upon sum of n terms is m square upon n square. You have to show that am upon an is equal to 2m minus 1 upon 2n minus 1. Now if you think little more, then what you have to show? You can write this this way also. A plus m minus 1 d upon a plus n minus 1 d is 2m minus 1 upon 2n minus 1. So your target is that you somehow you bring that a plus m minus 1 d, a plus n minus 1 d from what is given to you. So let's begin from this. We can write this solution, that Sm you can m by 2, this is 2a plus, and now Sn you can write this n by 2, 2a plus n minus 1 t, and this is equal to m square upon n square. So you can see that 2 you can cancel here, and this m will be cancelled by this one m, this n will be cancelled by this n. So now you are getting 2a plus m minus 1 d upon 2a plus n minus 1 d, and this is 2m this is m upon n, and you see this statement is true because it is given to you. Now next question is, if you work smartly, then you can find how you can get the answer. Here 2 you cannot cancel, otherwise you would have got a, but this way you cannot go. Now this 2 cannot be cancelled, so you have to make here some adjustment so that your answer this will come. So in true statement, if I substitute any value of m or any value of n both the side, then your this statement will remain true. So smartly, if you think that at place of m you need 2m minus 1, at place of n you need 2n minus 1. So this is something that you can get from the question itself, that you can replace here, replace m by 2m minus 1 and n by 2n minus 1. Now you may ask why we are replacing. We are replacing because we are seeing what we are required. So we required 2m minus 1 on the RHS side, and this statement is true. Like any identity, a plus b whole square is equal to a square plus b square plus 2ab. So this identity is true, whatever value you put for at place of a and at place of b. So similarly, this is a true statement. We can put any value of m both the side or any value of n both the side. This statement will remain true. So keeping in mind that basic concepts, we have thought of to substitute m by 2m minus 1, or you can say replace m by 2m minus 1 and n by 2n minus 1. Now we see what happens after replacing it. Now you see, if you do the replacement, then it is 2a plus, you replace m by 2m minus 1. So 2m minus 1 was already there, and here 2a plus 2n minus 1 minus 1d, and here it will be 2m minus 1 upon 2n minus 1. So simplify this further. 2a plus, you can write this 2m minus 2d, and you can write this 2a plus 2n minus 1d, and this is 2m minus 1 upon 2n minus 1. Now you can take 2 common from the numerator as well as from the denominator, so you will get 2a, here a. If you take m 2 common, then it will become m minus 1d, and this is 2, and you will get a plus n minus 1d, and here it is 2m minus 1 upon 2n minus 1. So this will get cancelled. Now this is your am, and this is your an, and this is equal to 2m minus 1 2n minus 1, and you have proved. So you have to see the question, basically what question is requiring, and this is the shortest method through which you can find or you can show what you are being asked to show. See this? Now question number 15. This an plus bn upon an minus 1 plus bn minus 1 is the am between numbers a and b. Then find the value of n. So am here, am means arithmetic mean. So am between two numbers is a plus b by 2. So this is the arithmetic mean between two given numbers a and b, and that am is given to you, that this is an plus bn upon an minus 1 plus bn minus 1. So you can start from here, that is that an plus bn upon an minus 1 plus bn minus 1. So this is given to you. So we start from here, that we do the cross multiplication. If I do the cross multiplication, then a into an minus 1 will become an, because here exponent is 1, here exponent is n minus 1. So when you multiply, then exponents will be added. So 1 plus n minus 1, 1 will get cancelled, you will be left with an, and then this will be a b n minus 1. Now then b, you multiply b a n minus 1, and this will be bn. So this is the cross multiplication you have done, and now you do multiplication like this. This is 2an plus 2bn. So now what you have to do next, you will bring all these terms, all the RHS terms this side. So now what do you get? See, if you bring this side, then it will become minus an, because an minus 2n will be minus an, and here if you bring it here, then it will become minus bn, and these terms will remain as it is, bn minus 1 plus ba n minus 1, and this is equal to 0. Now you have to take, you can take now these 4 terms, you make group of 2 terms in such a way that you will get factors of this statement, and if I take them together, then see what happens. I'm taking this b a n minus 1 minus an in one group, and a b n minus 1 minus bn in one group. This is equal to 0. Now from this bracket you see what is common. So common is a n minus 1, because a n minus 1 is the smaller one. So n minus 1 is common from here, it is b. Now out of an, if you take an minus 1, then only a1 will be left. If somehow you have a doubt, then you can again multiply this, that an minus 1 into b, you will be getting this term. If an minus 1 into a, because here exponent of a is 1, so when you multiply these two, the exponent you have to add, so it will become again an. So this way you can take the common here, and now here you see what is coming common. So I am just saying I can take bn minus 1 common. So if I take bn minus 1 common from this term, because minus is taken common, so plus term will become negative and negative 1 will become positive. So bn, it will be b only, and from here if you take bn minus 1, this will be a equal to 0. This is very simple. If you take minus common, then your sign of terms inside the bracket will change. I have done because I wanted the common factor. So now I have got common factor. So this is b minus a you can write, and this you can write an minus 1 minus bn minus 1 equal to 0. Now you see after this that now either b minus a will be equal to 0 or an minus 1 bn minus 1 will be equal to 0. But it's given to you that b minus a, you can remove this, that b minus a means b not equal to a, and now, and in this case, and we take this an minus 1, this bn you can take this side minus 1, and now you divide here that an minus 1 divide by bn minus 1. So an up minus 1, this is bn minus 1, this is equal to then 1, and this you can write this ab whole n minus 1, this is equal to 1. Now 1 you can write this as a upon b exponent as 0. So now you can see the bases are same, so your exponents will become equal, so n minus 1 equal to 0, and you will be getting n equal to 1. But here it is very important to see why this b not equal to a. You have to just think why this b not equal to a is given to you, and what happens if b equal to a. So you can also go and you can see, now you see this this term b minus a equal to 0, then I have not considered this to find the value of n. But what happens if I take b equal to a, means if I take b equal to a, will I be able to get the value of n? This is okay, this is fine, but here we cannot find the value of n. You see how we start from this one, that am, this equation number 1. So we mark this as from 1, we can say this is 1. So from 1 you will be getting, you can put all, you can substitute all the values, you can replace b by a. So your LHS this side will become a plus a by 2, and this will become an plus an upon an minus 1 plus bn minus 1. So you see what happens, this is 2a upon 2, and this will become 2an upon 2 an minus 1. You can also write this an minus 1. So this is an minus 1, and this is equal to 2 cancel, a and 2 here also get cancelled. So you can write this an, and you can write an into a minus 1. So an also got cancelled. So a equal to a. So in this situation you are getting both sides equal. So it means b equal to a is possible, but according to question you have to find the value of n. But in that case you will not be able to find the value of n. Okay. Now see question number 16. There are m numbers between 1 and 31. As a result, you will get this sequence as AP. So you see 1 is the first term and 31 is the last term, and this completing all the numbers, including all the numbers, they are forming AP, and this is given that 7th numbers and m minus 1th number, which the numbers which we have taken in between 1 and 31. The ratio is 5:9. We have to find the value of m. So here it's very important to understand that this is your first term, means a1, then this will be your a2, this will be your a3, and this will be how much you have to think now. If it is 2, then this is a3. If it is b1, then it is a2. So this is your am plus 1, and this term will be your am plus 2. So now in this we have first term as 1 and am plus 2 as 31. And now b7, if in according to terms we see, then b7 is actually your a8 and bm minus 1 is your am, and this is given to you as 5/9. So a8, you see, you put the general term formula, this is a plus 7d, and this will be a plus m minus 1d, and this is 5/9. So now you can see your value of a is 1. So you can write this as 1 plus 7d, and this is a 1 plus m minus 1d, this is 5 upon 9. Now if you have to find the value of m, you must have the value of d. So now we can find the value of d. You can mark this equation number 1. So you see how we can find the value of d. So you see your am plus 2 is given to you 31. So according to general term formula, this will be m plus 2 minus 1 d. This is equal to 31. This is your a. This is given to you, and this is 1. This is gonna be m plus 1 d, and this is 31. So from here you can get this 1. You take this side, then m plus 1 d will be equal to 30, and then d will be equal to 30 upon m plus 1. So mark this equation number 2. So using 2 in 1, what we get? 1 plus 7d. So we can simplify first in terms of d, and then ultimately last we will substitute value of d as 30 upon m plus 1. So 1 plus 7d into 9, and this is going to be 5 plus 5 m minus 1 into d. So you have this equation. This is 9 plus 9 7 is 63 d, and this is 5, and this is, if you open this, then it will become 5m minus 1 d. You can substitute the value of d as, we can keep it here d, we can substitute this at last. So this is going to be, you can bring it here. So, and you can take this side this. So this is 4, and this is 63d. This is 5 m minus 1, and 63 you can take this side, and this is d. Now you can simplify, you can find the value of m. You see how? So this is 4, you bracket you open, 5m minus 5 minus 63, and this is d, and d, the value of d is 30 upon m plus 1. So now you can again simplify this bracket. This is 5m minus 5, this is 63, so this is 5m, and this is 68. You cross this bracket, close this bracket, this is 30, and this m plus 1 you can cross multiply here, 4m plus 1. Now open the bracket, you can simplify, this is 2 2ja, and this is 2 15ja. So this is 2m plus 2, and 15 means 75 m, and this 0 4 you have to multiply by this 68 by 15. So you can multiply here, this is 15 5 40 0 4 30 38 42 2 carry 4, then 1 0, this is 1 0 2 0. So now you bring all the terms here, this side you bring this, and 2m you get it this side. So now it's going to be 2 plus 1 0 2 0, and this will be 75 m minus 2m. So this is going to be 73 m, and this is going to be 1 0 2 2. So you can now calculate the value of m. So now you can see this m will be 1020 divided by 73. If you simplify this, so you are going to get m as 15. So this is your answer. If you have liked this video, please share, subscribe and like it. Thank you.